how to troubleshoot electrical circuits. People, basically, all of you are searching for that and watching videos about that. So what can we talk about? Well, it's really straightforward. There's so many different ways of testing circuits. You might be a bit confused as to which method you should use in which scenario you're faced with. So I'm going to go through a couple of tricks, tips, and best practices. So stay tuned, you'll like this one. So there's that many faults on cars. What do I use? Well, let's start with the most basic of tools. A simple 7-watt bulb in a pen. So you ground it, and then the other side, obviously, you're going to put that on 12 volts, and it's going to light up. If it lights up dim, you've either got a bad ground, or you've got a voltage drop on the ground, or you've got basically a bad connection on your lamp, so make sure, check that. The other scenario is you've got a voltage drop on the 12 volt side. So is it useful? Not really. It's good for fast stuff. In the old days when I started doing this job, I used to when I worked at a place, first place I worked in Finland, I'd get a lot of stuff from the 1970s and 80s. Yeah, it was crazy, American stuff as well in particular. And I would have no wiring diagrams, so the way I would very quickly find out what was wrong with the circuit is I'd go to the general fuse box and I'd just flash every fuse with a test lamp and just check every fuse. And the one that didn't light the lamp up, obviously that was broken. Put it in, it would probably blow dead short. And then I'd work out on Google what circuit it was, you know. We're working on stuff without fault codes because they were so old. There is no fault codes. In fact, they were carburetted, a lot of them. There was no fuel injection, so you're just dealing with pure electrical circuits with no way of looking a fault code up. A bit more difficult, really. So that's useful for stuff like that. It could be useful for something like, say you have a fuel pump in the tank and you want to know, is it getting any power? There's no reason you can't stick a test lamp on the ground and the live. You put it on the ground with a test lamp. If it lights up, you've got 12 volts on the ground, meaning you haven't got a ground. So that can troubleshoot a ground problem. When you've got a bad ground, you'll have voltage because there's no return path of the voltage, so it's going to light up the ground. The voltage will just won't drop, it won't change states. There's no potential difference in the circuit. Yeah, it works. It can work like that. They're the basic uses. But what you can't do with a test lamp, what you should never do, is test engine control units or any type of control unit, because what will happen is you'll inadvertently short it to ground. Excuse me. Insects everywhere. Jesus. It's very hot today, 28. It's hot for a soft guy like me. When you, I saw someone do this once in Finland when I first started at a place. He was a good guy, just weren't thinking. And he destroyed a Honda. It was old Honda CRV. Engine ECU was a problem. And he wanted to check something, I think fuel injector feed. But he touched the wrong pin and it was something like another type of sensor or something. And it grounded it. It burned the ECU. There's no fuse, is there, in that sense? It won't react fast enough. So any type of control unit, never use 7-watt test lamp. You'll ground it. In fact, I can give you an idea of why that works. So if you need a ground to power something up because it hasn't got a ground, if you just get a 12-volt test lamp and ground it, instead of touching to positive to make it light up, if you just touch the tip to a ground source, it'll power something up. It'll glow really dim because something really weird will happen. But you can actually use it to power stuff up like a very primitive power probe. So that just demonstrates to you why you never use those test bulbs on anything major. Next one, LED test lamp. LED test pen. The scenario I just mentioned, that's when you'd use an LED test pen. It's not accurate though, is it? You're basing a circuit integrity on grounding an LED test pen and seeing whether the LED lights up bright. It's harder to see an LED than a big massive bulb in it. So if it's dim, in theory you've got a voltage problem, but it's safe to use on engine ECUs and stuff. So that's if you've got really basic stuff, them 10 quid LED pens. So, but LED pens are very useful for checking fuel injection pulses. So essentially if you put the LED lamp, some of them can automatically detect polarity like the Worth ones. They're only cheap, but you don't need to put it on the ground and then go to a positive and stuff, or go to a positive and go to a ground. So if you want to check a fuel injector with a Noid lamp and you don't have one, LED test pen, it'll detect the polarity automatically. Essentially, you just put it on the feed from the ECU and you'll see the pulse width duration displayed as LED flicker, but it's going to go so fast you might not see it. And that's when it comes on to our next thing. You're probably using an oscilloscope. So if you were suspecting fuel injector not working, not firing, transistor burned in ECU or something like that, probably what you would do is you just use a test. Like you can test the transistors with flute meters and stuff like that. You'd switch the engine off, disconnect everything, compare it with all the other good injectors. So you've got a misfire in one of the cylinders, and use this transistor test. You can do a continuity test as well. And there's a lot of videos on my channel how to do that. Well, say you wanted to see it under live sort of operating conditions with the engine running, what you do is you just scope it. Scope the pulse width, modulated duty cycle, or the pulse width of the injector. Basically, how long it's staying on versus how long it's staying off. And you'll see it, and the signal will narrow as the engine revs, or it will widen depending completely on how you do the polarity. And then obviously, as it widens or narrows, depending on the way you've set it up, that will demonstrate that the ECU is commanding the injectors to stay open longer. So we use scopes for things like that. And in modern injectors, piezo's, you can't really check the resistance of a piezo because it isn't a solenoid, and every piezo is different because it generates its own electricity by crystals rubbing together under extreme pressure. And the crystals is what expand and generate their own voltage, and that's why on those type of injectors the ECU shuts it off with the ground. Otherwise it would just indefinitely be squirting fuel in an hydraulic engine. That's why you never ever disconnect a piezo injector, diesel or petrol, with the engine running, because then there's no ground to shut off the current, and to kill the current in the piezo. It'll just keep pumping it hydraulic the engine, and I've seen that actually once. Believe me, it'll just hydraulic it. I bet flute meters, multimeters. Well, multimeters are a bit complicated. There's that many functions on them. Now, you have to understand multimeters are usually made for industrial applications. Factory engineers, aerospace engineers, people who need to use way more functions than us humble mechanics. So on a flute meter, the main functions you'll use as a car mechanic fault finder is obviously voltage, AC, DC. You'll use resistance, of course, continuity. And sometimes you might want to use the amp function to turn your flute meter into an inline ammeter, in which case, say you've got a battery drain, well, you take your positive out of the voltage side, you put it in the A side, and you select direct current sort of amps rather than sort of AC. And then you simply pull off the negative terminal of the battery and insert the flute meter in series between the battery and the negative terminal. So the flute meter becomes like a bridge, a shunt. You can't turn the engine on, you'll blow the fuse in it. It usually only handles about 20 amps, but this is dead useful for if you've got a battery drain. You lock the car latches over, you lock it with the key fob, and it's more accurate than using an amp clamp, which is subject to a lot of interference. What else do you use in a flute meter? Well, continuity is very useful for things not under load. So when you use continuity, you must remember it's not an accurate way of checking the condition of a wire. There's no load on the wire. Better off using a halogen bulb for that. We'll get onto that in a minute. So the continuity test, you might have wire with one strand out of 500 strands because it's corroded, and it'll be a perfect continuity with probably 0.1 ohm resistance. Oh, I've got a good wire, you haven't. When you use halogen bulb or a load pro, load it, suddenly you'll have no continuity, you'll have massive resistance. Why would we use continuity? Think about if we do retrofits, so say we repair trunk wiring on a car, like an E61, E91, old BMW estate cars. What we need to do, we need to basically sometimes use these kits, not much smooth and cell, but the numbers, the ink numbers rub off, and that's a nightmare. You can't see, so you might have 50 wires, they're all the same colour, they're all yellow. How do you know? Continuity test. You just basically touch each wire until it beeps, and you put your probe on the other wire in the car you've repaired from the inside to the out, and when it beeps, that's the wire you need to repair on the outside. That's when we use continuity mainly. Halogen bulb test, load pro, that's the way you test things on the load. What else on the flute meter have we got? DC voltage, of course, for checking battery voltage. Self-explanatory. You ground your meter, you check for 12 volts on whatever circuit you're measuring. If you want to flip it the other way and check if you've got a ground, just put the positive part of the flute meter on the positive of the battery. Use the negative one, touch the negative side of whatever you're measuring. And again, you can use that for voltage drop, positive to positive, negative to negative. So let's say we suspect we've got an issue on the engine ground because we've no chassis ground to the engine, the strap's wrong. we go negative to the chassis, negative to the engine block. If we've got like 0.2, 3, 0.4, 0.5 volts, you've got a massive voltage drop, which will be much bigger when you try and whack the starter motor over. Same on the 12 volt side. You've all seen them videos online. Basically, if you've got a voltage drop on the 12 volt side, same thing. If you can reach battery positive to whatever circuit you're testing is positive. Say you've got a 2 volt drop, you'll see it. You'll actually see the 2 volts. Yeah, you won't see 10 volts. Not if you go sort of battery negative and the probe just on that circuit, you might see 10 volts. Like a conventional way of setting up a multimeter, but voltage drop positive to positive. If you've got a 2 volt drop, it'll show the drop, it'll show the 2 volts, what's missing. Very useful. Sorry about the wind. I've put captions on this. The wind ruins everything, doesn't it? So what else have we got? AC voltage on the flute meter. When would you use AC voltage? Well, you'd use AC voltage really on old things, old reluctance-based things, old crank sensors, old cam sensors, old wheel speed sensors, any type of sensor what generates its own voltage. If it generates its own voltage, a sensor, you'll pick it up with a flute meter. It'll go from sort of 0 up to say 300 millivolts AC. Dead easy. That's why you'd use it. And that really is generally all I use on a flute meter. Infrequently I might use the hertz measurement to measure the frequency of a device. I don't really need that these days, to be honest. You can measure duty cycle on flute meters as well to see if something's being powered, how long it's on versus how long it's off, but you don't really use that. You use only those 4 things I mentioned, really. Well, I do anyway. Next one, power probe. You've all seen the videos. It's the best tool ever invented. Why? Because I tend to work on a lot of older stuff, and occasionally I might need to apply power or a ground to a circuit to power it up. I can do both on a power probe, and it has a good, got a stone in my shoe, has a good system, good circuit breaker, so you won't blow it up. I've actually chipped it many a time. Anyway, that's one of the best tools. A lot of people think it's pathetic using a power probe. A lot of people are against them because they've never used one probably. And unfortunately, a lot of people, they get a lot of bad press, power probes. You get a lot of idiots using power and stuff up and blowing ECUs up because, they don't know what they're doing. But it's hands down, with 5 meters of cable, the most versatile tool I've ever used. Not only because you can measure things like duty cycle, pulse width, injector tests, but really just because it's just so handy and fast. Boom, I'm in. Back probe it, because it's a bit big, the power probe point. The probe's too big. Back pin it with a finer pin, boom, testing, done. Way faster. Because you don't have to worry about applying a ground to a meter like a flute meter. And what if you're working on front of the car and you're the battery's in the back like in a BMW, or what if you're halfway in the middle of the car? Flute meter's not long enough, is it? That's why I use the power probe for everything. Amp clamp, I think we've covered it, but yeah, for a fast, quick measurement of current draw, amp clamp's the go-to one. If something like air condition or air suspension compressors drawing too much current, you'll pick it up, won't you? Dead easy. Just go around the positive wire, measure it, or the ground wire. Take your pick. I'll leave it up to you. So that's what I use. The oscilloscope. You see all these heroes using scopes for everything. I do it only when I can be bothered doing it if I really need answers. Like I might have a LIN boss fault, I want to see the LIN signal. If it's all corrupted, I would still see that, because I hope you can hear this video, because the wind always ruins it. If you have a voltage on a wire, let's say it's a 9 volt LIN, doesn't mean it's working. There might be 9 volts, but signal might be corrupted. Are you with me? Noisy here, just give us a minute and we'll continue on that road. Bit of a nightmare here. People drive like knobs in this village, you drive too fast. Right, wind's giving me a lot of gibber. There was no wind before. When you have a LIN or a can can be, powertrain can is usually 2.5 volts, 2.5 volts, but it changes a lot because it depends if it's recessive or dominant phase. It depends if it's what load is on the bus. So, as a rule of thumb, you'll see 2.5 volts, 2.5 volts for can. Second way we can is measure the resistance with the battery disconnected. You can't measure it with the battery on, you'll get a really weird resistance value. That's all you need to do with CAN bus. Nothing else. Learning's the same. You basically just want to get a scope trace of everything. You can see immediately from a scope trace what you're dealing with. If I see a really rocky, rough signal, I know I've got corrosion somewhere. If I don't see anything at all, I know I've got a knackered unit pulling the bus down to either 12, up to 12 or down to ground. In which case I'll start unplugging units until the CAN signal comes back, based on fault codes, of course, or based on experience. And the other one you'll see on CAN bus is if the wires are see, when the wires are touching together, that's another problem. When it goes to ground, though, unfortunately on CAN, when it goes to ground, you won't have an issue with voltage. It'll be 2.5, 2.5, but on the scope it'll show it touching ground. Well, you wouldn't see that without a scope, would you? And measuring it with a multimeter to check for ground isn't so good either, or a power probe, because you'll be going through control units, so you'll probably see a ground anyway. It wouldn't work like that. So that's when you'd use a scope. 9 times out of 10 with the job I do, I can work it out without using an oscilloscope because I've probably seen the fault before. But if it's a new fault I've never seen, I'll give it a quick shabool, a quick test with the usual methods, and if I'm not satisfied, I'll scope it, because it takes 5 minutes to scope stuff. But on YouTube, there's a lot of people just pulling these scopes out. I haven't got time. No one's got time for that shit. I'm one fault finder in a reasonable sized company. I don't have time to sip coffee all day and discuss fault finding with people. I've got to get the problem solved immediately, and that's why I'll break a scope out only if I need to. What else have we got? I need to cover some other things now. What I've got? Yeah, basically, I've used all sorts of weird and wonderful tools over the years. Sorry about that. I've got bloody flies all over me. It's the season for it. There's lots of things come out now, like, for example, Power Probe. They brought out that amazing draw monitor last year. They never sent it me. They promised me to send me one, but they haven't sent it me. So I've basically realised I don't need it. It goes in the OBD port, and what it does, it basically gives you a graphical display, like showing what's waking the car up, and I guess it saves it, although I've not used it. But again, the idea is you leave it in the car and bugger off for an hour and come back and then replay it. But how's that going to help you? I don't think it's any good. So I bought something for €20 from Temu, and I actually used it to solve a problem. It's basically an inline fuse tester. So you take a fuse out, instead of doing the which I'll get onto in a minute, milliamp measurement, you stick this Temu thing in, it gives you a display of the amps. It's fantastic, it's very accurate, I tested it. And the fuse goes in that device, which takes place in the fuse you're testing. It's fantastic for checking for things waking up and stuff. Brilliant tool. 20 quid on Temu. I'll try and make a video one day about it. So, last thing, I guess, is milliamp. Someone's slagging me off a while back saying that's not the way to check for an active drain. Well, my friend, it is the only way, it's the best way. So you go to the fuse board and you just find which circuit's still active. You might get 0.3 millivolts on a 30 amp fuse, which I don't know what that is. 200 milliamps, that basically translates to when you use the Power Probe conversion chart. So that's how I do my job. They're all the tools I use, and I use a lot of them. But to sum it up, you have to do a job for many, many years to understand, and you have to fix literally hundreds of thousands of cars, as I have over 32 years nearly, to instantly work out in your head which approach you're going to take. Now listen, doesn't mean I'm always right. Sometimes I'm wrong. Sometimes I make a complete mistake and I start testing stuff the wrong way, basically. Depending, I'm getting old now, I don't think as sharp as I did. Don't beat yourself if you do that, that's life. Sometimes you can work on too many jobs, and instead of getting better, sometimes your head's so full of fault finding shit that your head mashes up, and then you're not diagnosing anything. Then half an hour into it, you go, Jesus, Ben, what are you doing, you idiot? You're on the wrong circuit. And then you switch tack, and that's why being a fault finder is so good for you. It's like being a software developer, although they get a lot more money than I do. Both jobs, they teach you how to think analytically. Sadly, in our industry, they don't pay enough, but there you go. It does help you as a person. You can think more than the average retard. Sorry, I can't say that word. I'll get in trouble. The average person who has less intelligence, shall we say. People who think they can talk again but can't. Anyway, that's it. That's the video. I hope that gives you something to go on. Next time you start testing, play this video back, and it will remind you of what tool you need to use depending on the circumstance, the fault type or anything like that. It's as simple as that. Do you know what? Let's do a quick bonus. Lad's waking up now, so we can't stay on for long. He'll need me in a minute. Sometimes I have to carry him. Let's do a quick bonus to finish the video. Why would you measure the current on a circuit? Well, think about it. What if you have a sluggish starting system? Well, you can check a voltage drop on the ground, but what if there is no kind of voltage drop? Very hard to differentiate between a knackered starter pulling loads of current or a bad or a voltage drop on a wire. Which is it? Is it the wire not providing the starter? Is it the ground not providing enough ground return? Is that why the starter's sluggish? Well, really, really hard to find that out, actually, to be honest. It's very, very difficult. In some cases, you can visually check the wiring, but then you can look at other things. For example, if you've got such a bad ground that the starter's so sluggish, there's going to be other systems affected, isn't there? Think powerful things like xenon headlights or blower motors inside the car, anything that draws loads of current, they might be sluggish as well. Generally, if they're not, there's nothing wrong with the wiring usually. Again, if there's no fault codes either for stuff like that, you know, with voltage problems, if you've got a good strong battery and stuff. The way to do stuff like that is simple. You just apply an external battery support, put it direct at the starter if you need to. If it's still sluggish, the starter's goosed, and you can confirm it finally by bench testing it. So that's one way of doing it, isn't it? And what else? Well, if you suspect some type of other issue with the electrical system, all I can advise you to do is get a good wiring data and understand how the system works and start isolating stuff. Wiggle testing is good if you've got intermittent faults. You don't need any equipment for that, do you? You just basically wiggle stuff until you find a fault. Use a recording device to capture it, whether the volts drop from 12 to 9 or 7, whether the scope changes its pattern, all sorts of things like that. Anyway, I'm off. I hope you liked it, and I hope I get some views on this video because, well, I'm not doing so good on this YouTube business at the moment. It's right gone downhill, but then again, most people are on holiday. But all I can do is keep plugging away at it. I'll catch you all later.